My name is Ari Lamstein, and today I'm going to talk about a Streamlet app I created to explore how America changed during COVID. Before I start, I'd like to see, just by show of hands, who here thinks that the community that you live in changed during COVID? Me too. This is a harder question. What data set would you use if you wanted to see how widespread the changes that you remember experiencing are? I just want to hear someone shout out an answer. Parking data. That's a good one. In my case, I have this very vivid memory during COVID. I live here in San Francisco County. San Francisco is both the city and a county, and that will become important in a minute. And I was walking in the hallway of my apartment building wearing an N95 mask, and I realized so many people had left my apartment building, they'd moved out, that I felt some kind of peer pressure to move out too. And in the past, I've done a few projects with census data, in particular, the American Community Survey. The ACS is the largest household survey run in America, and they publish what are called one-year estimates. Every year they publish estimates down to the county level. And so I decided to start exploring that data set to see what I could see about how San Francisco changed during COVID. This started as a Jupyter Notebook experiment, and it became an app. You can view it right now at census-explorer.streamlet.app. A point I want to make right at the start is that at the very bottom, it says view the code here, and that's a link to the GitHub repo. It turns out there's no data for 2020 due to COVID, so the best I could do was look at population estimates for 2019 and 2021, subtract them, and I think it was a loss of about 65,000 people. And I had no idea how to interpret that, because I have no idea what the normal population fluctuations are for San Francisco. So I made this graph that just shows a time series data of the entire data set, and you can see that it's a very big drop. I don't even have to point it out to you. I showed that to some friends, and they said, well, I'd like to see that as a percent change. And so that's exactly what the second graph is. And you can see that that big drop is a drop of about 7.5%. And as I was doing this in Jupyter, I thought it would be fun to let people see it for their own counties. And that's why I use Streamlet, and that's what those UI elements at the top are for. Before I go on, I want to just show some other features about the app. Once you see how San Francisco changed, a 7.5% drop, a natural question is, well, a lot of cities lost a lot of, there was that general trend of people leaving cities and moving to suburban and rural areas. So how significant is this drop overall? And that's why I created this rankings tab, which just does the exact same computation for all the counties in America. And you can see here that San Francisco is 816 out of 818, which means we had the third largest drop of all counties. The next lens that I wanted to view this data in was regional patterns. Are there any geographic trends of the data? And that's why I decided to create this choropleth map. It uses quartiles, which means that there's 4 colors and an equal number of counties in each color. The darkest color is the lowest 25% of the rankings table I showed you before, and the lightest color is the top 25%. And so you can see here that the Bay Area in general had a population loss. Texas, which we've all heard about having population growth, is quite light. But if you zoom in on Texas, you can see that they also had a lot of counties that lost a very significant amount of people. The final thing I want to say about this app is that the ACS has literally tens of thousands of variables. It's an entire project in and of itself to understand them, and especially to decide, well, what's relevant for the perspective of COVID. One of the questions they ask on the survey, though, really stood out to me. they say, how do you commute to work? And one of the options is, I work from home. And so there was actually a 400% increase of people who work from home between 2019 and 2021 in San Francisco. And that's even more significant, of course, when you consider that during the same time, we lost 7.5%. When I spoke to James about the possibility of giving a talk about this app, he encouraged me to talk about how the Streamlet app works, how the code is structured. He had this idea that a lot of people here might have heard of Streamlet, but hadn't used it yet. And so he encouraged me to spend the rest of the talk trying to get everyone to a place where you could go home and create your own app. And that's exactly what I'm going to do in the rest of the talk. I view this app as having 5 distinct parts, and I encourage you to think of these 5 parts when you're creating your own app as well. There's data creation, creating the data set, transforming it into ways that would make it appear nice in a rankings table or in a graph, and then doing the actual UI, running the app locally, and then deploying it to the web. And in the second column here, I list just a guesstimate from memory about how much time I spent on each part. And you can see 95% of the time, almost all of it was just getting the data set and then doing things with it to make it in a form that would be nice in a graph. The last 3 parts, which I spent almost no time on, are where Streamlet comes in. And the way that I make sense of this is that Streamlet is just very, very good at letting you create web apps that let people explore data sets. And that's why it's exciting, and that's why I wanted to give a talk about it. So I gave you a link earlier to the repo, and this script, gen county data, is what goes off to the Census API and creates the data set. My hope is that at least one person in the audience will find census data interesting and want to play with it and explore it too. There's a lot of comments in this file because the census data has all sorts of surprising idiosyncrasies. If you are interested in this and you read the comments and you still have questions, the last slide is going to be a link to my website. So I love talking about this stuff. You can come up to me after this or just send me an email. The output of that script is a CSV file, countydata.csv. And the column headers are actually pretty important. State name, county name, year, those serve as sort of an index for the data. And the remaining columns are the labels that actually appear in the UI dropdown. Total population, total work from home, and so on. The best advice I got while developing this app was from my friend Ramnath Vaidyanathan, who has built tons of amazing open source software. Conceptually, when I was building this, it all started, I've said this several times, in a Jupyter notebook. And then things got too big, like the Gen County data script. And so I put it into its own file. And then it created its own file, the data set, and I imported that into the notebook and was doing analyses. And then when I had a graph that I liked, I just copied that and pasted it into the Streamlet app. My mindset was, the Jupyter notebook is just scratch paper and the app is real. And the best advice that Ramnath gave me was, do not do that. Do not view this that way. Because these apps aren't like real web apps. They're sort of exploration tools in and of themselves. If you treat it that way, you're going to wind up duplicating code in a bad way, meaning at some point things are going to become out of sync and you're going to forget which version you like and so on. And so he encouraged me very early on in this project that whenever I'm doing a transformation of the CSV file, like creating a ranking table or anything, any operation on the CSV, should not happen in the app itself. It should happen in the separate file that I called the backend, and that my Jupyter notebook and the app should import from it themselves. That wound up being very good advice, and so I thought to pass it along. This is a simplification of the backend. There's a state UI. Where did the state names come from? I just query the data frame and call unique on that column. And this is true for something as trivial as that and for the more complex things like the ranking table. So now onto the Streamlet app itself. Streamlet is just a normal Python module. You pip install. The convention is to import it as ST. And the key thing to know is that any UI widget, any UI element that you want to appear on the screen should be a call to ST. So the trivial example is the header. How did your county change during COVID? You just call st.header. How did your county change during COVID? For something like the state dropdown, which is programmatic, you just call st.selectBox. The first parameter is the label, state colon, and then the values are a call to the backend, be.getStateNames. I thought that some people here would want to know, well, how can you learn more about Streamlet? The way that I learned about Streamlet was from something called the 30 Days of Streamlet Challenge. It's something the folks at Streamlet put together 2 years ago. And the idea is that every day you get one small, it's totally free, I should say. Every day there's one small little exercise, they build on each other. And at the end of the month, you're pretty much in good shape to take on a small app like this. In terms of running the actual Streamlet app file and seeing it in a browser, after you install Streamlet, it installs this executable called Streamlet, and you just type Streamlet run streamletapp.py. That's just the convention to call the app that. There's no configuration at all. It just works. What really impressed me about Streamlet is how easy it was to deploy the app to the web. Not only is it free, but it's easy. You go to streamlet.io/cloud. You can log in with your GitHub credentials, and then you just give it the repo that you want published or deployed. And then you have to, of course, select a branch and a file. The initial deployment takes a minute or two, but after that, they use commit hooks, so you never have to think about it. Every time you make a commit, your app is automatically updated. And in the 2 months or so that I was using this, I never once had a problem. It worked really well. That's about all that I had to say about the Streamlet app. I want to just recap the main points. The what is an app that lets people explore how the demographics of their county changed during COVID using data from the American Community Survey. How it works is primarily Streamlet. But if you want to build a similar app, I recommend thinking in these 5 terms of how you're going to create the data set, how you're going to transform it, keeping that in a separate file, and then using the UI with Streamlet that you could learn more about through the 30 Days of Streamlet Challenge, and then running it locally and deploying it are pretty much taken care of for you by Streamlet. As a reminder, the app is at census-explorer.streamlet.app. And at the very bottom is a link to the GitHub repo, so you can view the code there. And finally, the part of the app that I talked about the least is the census data itself. And I've written a lot of blog posts about that. So if you're interested, you can view them at arilamstein.com/blog. Thank you very much.
Yeah, thanks, Ari. That was great. And you'll have maybe put the link to your repo and all that in the meetup comments or something like that. Probably a good place to get it. Any questions for Ari? Actually, don't run away too fast. I got a question, Ari. Yes. As long as they don't fall over the chairs.
Yeah, are the images pre-generated or are they generated on the fly by Streamlet?
Any other questions? Yeah, Chris has one.
Ari, thanks. Great talk. I'm not familiar with the Census Disc package. What did you use that for in the project?
Can I ask you to hold that for a minute?
Yeah.
Yeah, so that's, I cut out all of the census stuff from the talk, and so I'm glad to get a question about it. Census Disc is a package for working with the Census API. And there's a lot of nuances with census data that it makes it really easy to deal with. The guy who wrote it, Darren Venkoff, he was very helpful. I asked him a lot of questions, and I wanted to sort of show you how I learned about it and what it can do. Last year, Darren gave a talk at PyData Seattle. It was not a talk, it was a 90-minute workshop, and it was recorded. And so you can follow along with it and see walk through example analyses of census data with him. You're going to need to deal with things like FIPS codes, which are code. I mean, how many counties do you think are named Lincoln? You know, so they all have a unique ID, right? To get around that. So you may want to ask questions like, give me all counties or all tracts in a certain county. So there's nesting of the geography. And it also goes, the Census Bureau also produces maps for all these geographies. And so you can easily create maps of them through there. So it's a fantastic package. And Census Disc, I'm on the GitHub page, and this is a link to the video.
Thanks. Any other questions? Oh, over here. Oh, sorry.
All right, great talk, by the way. How much front-end experience do you need actually to write some apps in this? Do you need any front-end experience? Do you need any experience in the front end, like with any?
Oh, no, you need no front-end experience. I've done a bit of front-end programming in the past, but this is I mean, this is it. The thing that most impressed me was I've used other frameworks like this in R, and I remember struggling to create things like tabs and columns. And so this is, a tab set of 4 and eat that as 2 columns. It was so easy. You just say st.tabs, and you store them as tab 1, 2, 3, 4. And then with tab 1, put this here. With column 1, put this there. There was nothing that I needed to do at all. And that really impressed me. It surprised me.
Okay, any other questions? Okay, Ari, well, thank you. I know what you mean about the front end. I don't do much front end. I mean, I do many things, but not that. And so that kind of interested me too. I'm going to go off and